So I think we still remember more than 2 years ago lah. There's an incident happens. I think six people have actually life gone dead by this incidents okay. So I think it's a very serious incident in this case, because this debris and mudflow actually have caused devastating damages to not only to properties and also the human life. As you can see from the photo when a lot of muds and debris coming down from the high hills or whatever, basically the whole river channel will be actually silted up or choked out. Water actually it will be overflow the bank. There's no river channel anymore. I think the river channel, the fill up the debris is until the bank level. So all the water actually will be overspilling the bank and actually start to inundate the surrounding area, not only with water but also with debris and the rocks, everything that is washed down from the steep hill. Okay, I think recently there's an incident also. I think recently from Karak also there's a mudflow incidents happen. Okay, I think this happening become more and more frequent. I think one of the main reason is the land clearing lah. But in this Gunung Tirai, it's not land clearing. It's a natural disaster where I think maybe the ground is very steep and also the rainfall is very heavy. Okay, so at this incident at the Gunung Tirai here, in 2021, it was recorded that the rainfall is around 280 mm fall within 6 hours. And check with the IDF curve, the intensity duration frequency curve, from the DID GPS station nearby this area, is the recorded return period, or we call it ARI, average recurrence interval, is recorded to be 70 years ARI. Okay, it's quite a high rainfall event. Okay, so after this incidents, the government have actually proposed 2 locations to construct the Sabo Dam. Okay, one is at Titi Hayun, the other one is at Tupah. Okay, as we can see from the location, Titi Hayun, actually the river is flowing through the Sungai Dara Mandi, but else the Tupah Sabo Dam is for Sungai Bujang. Okay, so the location for the 2 Sabo Dam. The objective is to plan and design and construct Sabo Dam structures upstream of Sungai Dara Mandi, adjacent to Titi Hayun. I think Titi Hayun is a very famous resort area. Due to this incident, the resort area have been closed for I think 2 years. Okay, I think recently it opened up for public to again. Okay, the other one is at upstream of Sungai Bujang, where there's a water intake, Sada water intake there. Okay, so it's also a very critical location to protect the intake from damage by the debris and mudflow. Okay, these are the 2 locations that have been earmarked by the government to implement this project. The emphasis is to place structures or to control the debris flow, include rocks, logs, sediment, and any hard materials from actually flowing downstream and causing major damage to the populated area. Okay, so the target is to minimize the impact of waterhead incidents, which cause high risk to human life and also environmental degradations and also property damage. I can see from the photo itself just now. Okay, data collection, I think it's quite standard. The data collection, we need to collect the rainfall data. Okay, then the satellite image, the topography maps, the contour maps to get the catchment characteristics of the area we are going to design to locate the structures. Then we have drone to fly along the river corridor to check which are the suitable area, because I think the area is quite steep and not easy to access. So I think drone helps a lot in this sense, where we can capture video, images, and all these things to check what is the best location to actually to locate the Sabo structures. Survey also, after we actually identify through drones, we do a ground survey, engineering survey, to get the cross sections and site survey of the area. Okay, for these two locations. Then also the SI, SI to determine the soil condition or rock profile along the proposed location. Okay, later on for the design of the foundation, and also to check for the seepage problems if there is. Okay, design criteria. I think in Malaysia there's still a lack of design criteria for these Sabo structures. That's why we actually refer to a lot of guidelines from overseas, especially from Japan. These are the list of guidelines that have been adopted or adapted into these local conditions. Okay, especially from Japan. I think you all know that Japan are quite famous. Sabo, actually, the name also from Japan is actually the meaning is to control of sediment. The meaning of Sabo. Okay. So from all these data collections and the guideline, the first thing we need to do is establish the flow of water first. Okay. So standard, I think I will be very quickly go through this. Okay, it's just a demarcate catchment, then get the design rainfall intensity, then get the catchment characteristics. Then we use some hydrological procedure to estimate the runoff lah. Okay. So the catchment area for TT Hayun is almost half of Tupa. Okay, for 4.8 square kilometer and 9.8, 4.6 and 9.8 square kilometer respectively. And this is an IDF curve at the nearby station. Okay, from hydrological procedure number 1. Okay. Then the runoff estimation, we have used two HP5 and HP27. These are two suitable for actually rural and undeveloped area. Okay. I think you all should know about this, HP5 and HP27 for those who have used it before. Okay. And the other one we have adopted is using the rational method that was proposed in the JICA guidelines. Okay. We also use this to compare with the HP5 and HP27. Okay. After the computation, we found that these are the listing of the, there's a B, I think you all hear that. Sorry for that. Okay. So HP5, HP27, and the rational method, the Q peak are listed here. From the computation, we can see that the rational method giving the highest flow peak lah. I think that is what I think most of the consultant will get also lah. If you rational method, normally you provide a higher Q peak lah. Okay. So for Tupa also the same characteristics. This is the listing of the various return period, and this is the Q peak from hydrological procedure. Number 5 giving the lowest. Actually 27 is in middle, higher, actually much higher than HP5, but rational method is a bit higher lah. Okay. So from the results, we can see that the rational method is almost 90% higher than HP5, and the HP27 is lower by almost 15% compared to rational method for the 100 years return period. RI. Okay. Actually, rational method provide a higher Q is because actually they adopted runoff coefficient is also high as recommended in the guideline. Actually, there's a possible reason for this also. In Japan, I think most of the land use is very rocky because they are volcanic type of soil. Okay, not much plants or vegetation at the area there. Okay, so this actually they are recommending a high runoff coefficient. 0.8 was adopted in this case. Okay, but because of the uncertainty, in this design we have adopted the rational method as the higher value that we have adopted to design the sizing of the Sabo dams at both Titi Hayun and Tupa locations. Okay, Sabo dam sizing. In this project, the recommended type of Sabo, there's a closed Sabo and open Sabo. Just to explain a bit what is closed Sabo and open Sabo. Closed Sabo, that means the Sabo dam is intended to trap also the sediment. Okay, but open Sabo is just to trap the debris and bigger size rock. Okay, so that is the difference. Okay, so in this case, actually, we are not intend to trap the sediment, but only the debris like tree trunks and also the boulders. Okay, so this is a function that was adopted. This design criteria was adopted in this design. Okay, and actually with this structure also, it would not only trap the debris, but it's also reduce the flow rate. Okay, you have a stable structures in front. The flow velocity here will be greatly reduced. Okay, when it reduces, it will help to deposit. Although it's open Sabo, but after a while, the Sabo also will actually trap sediment behind it because it slows down the flow. Okay, so it acts also as a guide, flow guide to prevent spread of the eroded area, eroded sediment and also debris, and also limit the flow of the eroded material and debris. Okay, these are the functions of the Sabo. And these are some examples that we have for the open Sabo, the concrete type or the steel frame. Okay, we can use steel frame also. Okay, Japan, they use a lot of steel frame also for their to trap the debris and boulders for the open Sabo. Okay, concrete also have been used. Okay, so we also consider why we actually finally we adopted the concrete Sabo. I think both are effective. Okay, construction cost, I think we estimated the steel Sabo will be a bit higher, and structural stability, because the steel frame is light, we need a very strong foundation. Whereas the RC Sabo is also act as a gravity dam to retain it. So in stability wise, it's more stable. Okay. Construction duration, definitely, I think the steel structure will be much faster because it's most of the members will be fabricated in the factory. Then I think it will be mounted at the site. Okay. Construction difficulty, I think steel structure may be a bit difficult because you need to transport the fabricated steel column or whatever, okay, beam to the site, okay, and quite heavy when we want to install it. So construction difficulty, I think, is a bit difficult for the steel structures itself. Debris maintenance, because you can observe just now the steel structures, the tree trunk can be trapped in between. If trapped in between to take the debris out from the steel frame, it's quite very difficult compared to RC structures. Okay, wear and tear, I think definitely, I think steel is easier because it's subject to corrosions. Okay, finally, the RC Sabo was adopted in this design. Okay, this is a general structure components for the Sabo structures, where you have the main structure, Sabo structure, main Sabo structures. You have the opening. Okay, Then you have the apron. Then you have the sub-Sabo dam. Okay. This is basically the adopted Sabo configurations for these projects. And the first thing is to estimate the debris volume. I will not elaborate much. Basically, is estimated the length of the stream, and there's a way to estimate the volume of the debris, estimated debris, and also the what is the collapsible volume that go into the channel itself. Okay, from this we know the length of the stream, the width, everything. From there, we actually estimate the volume of debris that will be going to this intended location for the Sabo. Okay. Definitely, I think the more data you collected, then the more accurate the volume is it. But at this moment, we just based on the stream length and all these things to estimate the volume of the debris that coming down. Okay. Then the other thing is we need to estimate, after we know the volume of the debris that is going to wash down from the event, then we need to estimate the volume of the Sabo that can trap this volume of sediment, debris and boulders that coming down. Okay. So actually the location of the Sabo is very important. The more gentle the riverbed is, the bigger the volume you're available. That's why just like I mentioned, we have to do the drone and survey to get the good location. The wider the river channel, the gentler the river channel, then you can have a bigger area for trapping. Okay. So the volume of computation for the volume is at this triangular. Okay. There's a formula here. I will not elaborate much on this. This is the volume. This is the triangular shape times the width, okay, to get the volume available to trap the debris from coming down for each event, okay. Definitely, I think this, we assume that the Sabo will be actually maintained very well, where your Sabo have to be clear whenever there's another event that debris have washed down, okay. But sensitivity analysis also being carried out in case the Sabo is a quarterly fill or half fill or whatever, okay. That can be done in the modeling part, okay. Then we actually estimate the spillway on top of the Sabo. We don't want the Sabo to overspill everywhere across the dam itself. We need to allocate a location where the Sabo is overspill if the event is much higher, or your Sabo structures, your Sabo debris, you have no time to empty it out. Then if it's full of debris and boulders, the water may overspill the Sabo dam. So we design the weir accordingly, okay, to get it computed to take what is the return period and estimated the flood level, okay. Let's say in this case, it's 100 years return period. What is the overspilling? Okay, and we want the weir to be downstream of this weir is your apron, so that it control the hydraulic jump or dissipate the energy when the water overspill the weir here. Okay, and there we design the plunging pool where actually when the water is overspill, it drop into this apron rather than outside the apron. That's where there's a formula to compute the length of the apron required, and the width of this apron and the sidewall will be actually based on the weir width that has been estimated from the queue. Okay. Then we also estimate the debris peak discharge and dynamic force. It's important to estimate what is the highest peak for the debris, and also what is the dynamic force that act onto the structure itself. Okay, so this is the formula used to estimate the design peak discharge for debris flow. Okay, so this is the formula. I will not elaborate. Okay, and this is the height of debris, depth of debris estimated using the peak discharge debris that has been computed from here, and this is the velocity of the debris flow. From there, the H and V with other parameters, okay, then we compute the force the act on the Sabo structures. This is for structural design of the Sabo itself. Okay. And this diagram shows the forces. As mentioned just now, the F is to compute these forces, the forces of the dynamic force of the debris to the structure, and other forces like the weight of debris, weight of sediment, earth pressure, and hydrostatic. From there, we estimate if it's a gravity dam, then the weight of the dams have to withstand all this sliding and overturning everything. Okay. After all this, we will hand over to the structural engineers and geotech engineer to design the main structure and the substructure itself. Okay. So this is basically how we size up the Sabo dam. From this, actually, this is a dimension that have been estimated from just now the formula and also the computational method, the guideline provided. Okay. This is for Titi Hayun and this is for Tupa. And to summarize the whole thing is, actually the catchment area as mentioned for Titi Hayun is this one. The dam height estimated is 7.4 based on the width of the river channel and also the volume required. Then we determine the height of the dam. The volume of debris we want to control and the width of the river channel at the location of Sabo, then we determine the height of the Sabo dam. Then the proposed bed level, top dam level, what is the reduced level? This is then overspill weir. Okay, this is overspill weir level. Opening, how many slot we want for the open Sabo. Then this is the storage volume available, 22,000 meter cube. Okay. For Tupa, it's bigger and higher the dam. Okay, this is the value. Okay. And the storage volume debris computed is 41,000 because the catchment is almost double the Titi Hayun. After we size up the dam based on the guideline provided in the formulation just now I presented. Okay, we also put into this. We also model the debris using the Kanako debris flow simulators. Okay. This software actually is can be downloaded free from the internet. Okay. Actually, is developed is based on theoretical principles of debris flow and supported by laboratory experiment and field data from Japan itself. And there's a 1D and 2D model. Okay. The objective is to develop and carry simulations using this model. The aim is to model estimate the debris flow discharge along the slope as to verify the effectiveness of the design Sabo dams as Tupa and Titi Hayun. That means just now we have sized it out, then we use this model. How effective is it to retain the debris? Okay. And this model also has been used by UTM for the Cameron Highland studies and also by UKM. Okay. So basically, the flow chart for this Kanako modeling is we need to know the landform as mentioned. We need to know the cross section, the view, or all these things along the stream itself, and also at the Sabo structures. Then we set up the after the landform. Okay, we will set up the model itself, setting it up onto the model itself. Then we also apply the hydrograph. That means the peak discharge and the sediment concentration. Okay, the debris flow concentration. Then we run the simulation. Then from there we get the flow depth and sediment thickness. Okay, that's the results. Okay, and this is the input. This is all the input. This all from the survey itself. Then this structure is just now we computed. Okay, then with the hydrograph we put it in. We supply then the initial, what is the thickness of the mold. This is all estimations from the site investigation. We estimate how deep when the sediment thickness it reached the hard ground. Okay. Then the points we want to estimate the flow. Okay. Then we see the output is the display discharge hydrograph. Okay. Later I show you the results. Okay. So this is the setting up of the model, okay, 1D model and 2D, okay. just now, this is the for the Sabo, the observation location. We have two location. One is this is Sabo. One is upstream of the point, and the other one is a downstream of the point. To compare. Okay. Then we put in all this height of the Sabo dam, as we have actually estimated just now. From there, we put in the discharge for 10 years and also for 100 years, as computed by just now the formula. Okay, this for TT Hayun is for Tupa. Then we put in the simulation parameters. Okay, from there, the results come out for 100 years and 10 years. Okay, we can see that for TT Hayun, this is for 10 years. The upstream of the Sabo is, this is the hydrograph coming down. And after the Sabo, it's become from almost 15 meter cube per second to 6. For 100 years, it retained more because I think because it's open Sabo, from 43 like that, 42 meter cube per second can reduce to 10. Okay, these are the results. For Tupa, I think it's a similar observations. Okay. Then from there, we can see that the Sabo is actually effective in reducing the amount of debris flow from upstream. Actually, for 100 years, it's almost like 4% reductions for TT Hayun and for TT Hayun. For Tupa, it's almost 82% reduction. Okay, for 100 years return period. You can also observe that the percentage of reduction of the debris are even higher. You can see that. Okay, the models have demonstrated that with the implementation of Sabo structures, okay, at the proposed site, the debris flow discharge at the downstream stretches of the river can be greatly reduced. Okay, let's say a similar event that happen again after the Sabo structure, the debris discharge from the dam can be controlled and can be reduced to a manageable levels. Actually, this modeling also, as mentioned, can be used to do some sensitivity analysis. Okay, let's say the Sabo is half full. We can change the landform of the model by filling up the upstream of the Sabo with some sediment to increase the bed level. Then we can see how much it can trap if it's just half full or quarter full or this. Okay, so the modeling can actually simulate situation that can provide us some indication if the maintenance cannot be what is the consequences can be happen if it's half full or quarter full or 3/4 full. Okay, so conclusion is we can see that the overall model simulation prove that existing Sabo can actually control the debris and greatly reduce it. Okay, and then the estimated sizing of the dams, Sabo Dam at Tupa and TT Hayun, can be effectively control the debris flow based on the model results. Although the model has its own limitation and assumptions, the results can be used as a good indication in determination of the effectiveness of Sabo dams at both location. Hence, it can be avoid the disastrous consequences as compared to without the Sabo. Okay, as mentioned, we can also simulate for different scenarios. Okay, or even climate change. Here we just want to show some layout of the completed structure itself. Okay, so this is the general layout of the Sabo structures at TT Hayun, where you can see this is the Sabo structures, and this is we need to actually do a band here because this land is actually a private land. We also don't want to encroach the Sabo structure into the private area, so actually we do a L here, a band here. If not, we can actually straight away go through directly link to this side of the slope itself. Okay, so this is the capturing area for the debris. Okay, so this is the apron. So this is a maintenance access where road have been constructed for maintenance of the Sabo structure itself. When sediment is accumulated here, lorries and excavator can go down and and clear the debris that have accumulated behind the substructures. Okay, this is the side cross section. Okay, profile, and this is the front. Okay, front view. And this is for Tupa, similar configuration. But for Tupa, last time, just now I mentioned there's a Sada water intake. Last time is located, without the Sabo, is located around here. But with Sabo, we actually created another storage for the Sada water intake downstream of the Sabo dam, so that this Sabo intake will not be damaged by any debris flow or whatever, because it's controlled by the structure itself. Okay, and we create a pool at the side here, where when normal time water can actually, from this punching pool, actually add additional storage to the for water supply purposes also. Okay, with these support structures. Okay, this is a section and the front view of the structure itself, and this is a completed structure looking upstream. This is we are standing downstream looking upstream. This is the apron. This is the open Sabo. Okay, and I think this is the Gunung Jerai lah. Okay, up here. Okay, and we have some telemetry and siren and warning also. Okay, this is from upstream looking downstream. Okay, this is a storage area. Okay, of the Sabo. And this is another view, standing on the left bank of the river. Okay, this is the downstream and this is the upstream. Okay, and this is Tita Hayun. As mentioned just now, there's a pond here created for Sada water intake. Okay, this is the telemetry system. Okay, we also have monitoring system for the integrity of the structure. Okay, if there's a big movement, then I think it will be detected. Okay, so this is the apron, and downstream of the apron will be protected by riprap. Okay, this is a punching pool, and this is looking from upstream to downstream. Okay, so basically, this concludes my presentation. Thank you for your attention, everybody. I hand over the floor back to Engineer Chow.
Okay, thank you, Engineer Dr. Wong, for the presentation. So I think we allow some time for the participants to post any questions. So any participants, if you have any questions, you can post your question into the chat box and I will read it out from there. Over here, there's a general questions. I think it's directed to both speakers. From IR Liao, she's asking whether the deck will be shed. So that one, I leave it entirely to the speakers.
Okay, I think we need to discuss among ourselves first.
Okay, no problem.
Okay.
Yep.
Okay.
Okay, we have a question from Mr. Muhammad Ijaz. May I know what's the frequency of the maintenance work required for Sabo Dam?
Until just to share some the Sabo structures is almost completed 1 year already lah. Okay, so far there is one incident that actually the debris have been accumulated. One event happened. Okay, but the debris accumulated behind the Sabo, I think it just roughly less than 1 meter lah. So but when I think the whole year, this 1 meter, I think the contractor have been asked to clear it so far. Okay, we are not so sure because debris is not like rainfall. Okay, like if the debris happens in one big event, the next big event the debris will be much less. Okay, it's not like same as a runoff where same event the runoff volume may be the same, but debris, if the loosened debris have been washed down, the next event, if it's very near to each other, then the debris can be much lower lah, the volume as compared to the first event. When there's a long time, there's no high event, the debris accumulated and all these things will be more if the event interval is longer. Okay. So far, as I mentioned, there's one incident only. The contractor need to go to maintain the Sabo structures. Okay. I hope I answered the questions.
I have a question also following up on maintenance. Usually, who's the one who operate and maintain the Sabo? Like for this case, is it by JPS or is it by contractor, concessionaire, or how does it work?
Okay. Because this project is a design and build. The contractor in their contract is they need to do 2 years maintenance period. So it's within these 2 years, it's all under the contractor who clear the debris. After the 2 years, the whole structure will be handed over to the project owner, JPS. Then JPS have to decide to how they want to assign to the state or whoever to to maintain the Sabo itself. Okay.
Thank you, Dr. Wong. So we have a few more questions over here. There's one from Engineer Zainal Abidin. How long was the construction period?
The construction period was given 18 months for this. Okay.
No extension, completed
no
on time.
extension. Completed ahead of time. What I
Oh.
come to know ahead of time. Okay.
Okay. The next question we have here from Mr. Lee Sun Chai. Does the dam has to go through annual inspection?
Okay. As I just want to share this open Sabo is not like water retaining structures. Okay, like those normal reservoirs. Okay, because it doesn't hold water behind it. Definitely, I think the requirement for inspection is not as stringent as those water retaining dams. Okay, you don't have a seepage problems and all these things. Important thing is whenever there's any incidents, I think there's an inspection need to be checked on the structure itself. Is there any cracks or whatever damage to the structure itself? I think that is what I see is the main thing need to be checked. Okay.
I also have a question following up on that.
Okay.
Other than dam requirements, safety inspection requirements, how about environmental EIA, or does it fall under prescribed activities?
No, in this sense that because you see it's open structure, it's just like any. I look at it. You can relate to stormwater. It's a big GPT . It's a big gigantic GPT . Okay. Just to highlight this dam, because we also install some gauges inside the structure itself to monitor the movement of the dam itself. Okay. Just to highlight that so that they are monitoring the integrity of the dams also frequently. Okay.
Okay, we have another question from Mr. Wan Muhammad Asri. What are the safety factors and stability analysis required for the Sabo structure?
As mentioned, actually, for these Sabo structures, it's same as any because we go for worst case scenario. Okay, the worst case scenario is behind the dam. It will be fully filled. Although you can see the dam got slots, but we assume that the dam will be fully filled with debris and also sediment. Okay, and also on top of that, there's I just go back to the forces. And also there's a dynamic force acting on top of the structure itself. Okay, so this is the most critical force. This is the forces that recommended to be considered in checking the stability of the dam itself. Okay, so the hydro force debris that is just now I show you the formula. Then the weight of the debris, the hydro earth pressure, hydrostatic pressure, all these are act as to compute the requirement for the stability, overturning and sliding of the dam itself. Okay.
Okay, thank you. We move on to the next question. We have it from Mr. Andy Iqbal. He's asking, Sabo dam is designed for water heat purpose. Is it practical for other industries usage? For example, mining industry where there's debris from blasting affecting the rivers.
I think definitely if you foresee because Sabo structures is designed whenever there's a heavy runoff from a catchment that consists a lot of loose material. Okay, if you let's say actually you no need to like mining industry or this, you no need to have a concrete, a massive concrete structure. Actually, we call it Sabo structures. You no need to be a very big structures. Okay, it's just like when you design your sediment trap or whatever. Actually, you can control at source. You can have a smaller. Actually, there's in the market. There's like a cage like that. All this. But you need to anchor it properly to actually hold your boulders, your rocks, everything. From actually going downstream of the river. You can actually there are smaller structures, Sabo structures. We call it Sabo structures, not dam, to control the debris from the smaller catchment. Okay.
Okay, thank you. We have a few more questions. This one is from Mr. Teh Chong Kui. Does the Sabo dam design based on minimum 100 years ARI, or it can be designed based on other clients' preferences?
Okay, to be frank, I cannot answer that, but we based on 100 years because in Japan, the guideline is mentioned that we design for the 100 years return period. Okay. But we don't want to design very serious. You can design for 10 years or 20 years. It's okay. It's still okay. But we need to do the sensitivity analysis. Okay. Because if we have the model, let's say you design a storage volume for this, let's say 10 years flow or whatever, then your weir will be overspilling whenever there's high flow. Overspilling, the like tree trunks that may be lighter than the water, you can overspill your weir and go downstream. All this you need to consider what type of material you're going to retain. Okay, you can design for 10 years or 50 years or 100 years. I actually cannot have definite answer, but from the guideline from Japan, their Sabo structures are designed for 100 years so far. I hope I answered the question.
Yep. Okay, thank you. The next question from Mr. Wan Muhammad Asri. How will the Sabo structure be integrated with the existing topography and stream channel?
Okay. Yes, as I mentioned, you need to select a location because a Sabo structure, the main objective is to retain material upstream of it. Okay. The bigger the basin you have, the more volume you can retain. But to integrate into the system itself, it depends on how because at this moment, it can be structures where actually it can be a recreational, like the TT Hayun at this moment when we have this Sabo, the apron for normal time, the people, because that's why we purposely designed for 1 meter water depth so that children all this can play at the plunging pool there You want integrate, that means it's become part of their recreational pool, swimming pool like that, or all these things
So currently it's open to public, is it?
Yes. But problem is some people go upstream of the Sabo. That's the issue Safety problems also When you open up downstream, people may just curious and walk to upstream because the slot is wide enough for people to go through it. Yes.
I see. In Indonesia, in Japan, it's also open to public, right?
Yes.
Okay.
That's why they have siren from actually now there's a siren even to detect let's say heavy rainfall in Gunung Jerai upstream exceeded a certain threshold, then the siren will be on so that they warn the people downstream there to get evacuate from this area
The warning system, is it purely based on rainfall?
And water level too.
And water level.
Yes.
Okay, we have a few more questions. We still have a bit of time before the next session, so we go through all the questions as much as possible.
No problem.
Okay, we have a question from Miss Hani Zaida. Since the original blockage has been washed down, would a repeat incident at the same site be of lower probability? Why not build the Sabo Dam at other identified risky area?
That is a very good question. Uh, just like the question you asked, if that area being flooded, the chances of it being flooded again will be less, correct? So we we have to assign, but it differs, okay. In Malaysia, I don't know lah. We have limited fund, so we normally go for difficult to say also, almost crisis management. Okay, that means whenever there's an incident happen, we try to solve that problem at that time lah. Okay, definitely I think we do need a master plan. Actually, my personal thinking, we do need a master plan. Actually, maybe JPS also planning for it lah. To study the potential area that debris flow can happen. So from there, we can actually put up a more effective implementation plan for these Sabo structures. Okay, I don't say it's dam, Sabo structures. It can be any smaller structures or whatever to control. Okay. Incidents happen like we have Baling also. After this incident, Baling also got one incident, the debris flow, and also Karak very recent. All these are at the very hilly and difficult terrain. Okay, definitely. As you said, once the material have been loosened and washed out, the next round will be probably will be less. I think you can be right in certain degree lah. We understand that, but because that incident happened already, the potential of it happen again also be there lah, because it happened already, and the Gunung Jerai, there's no logging, no agriculture, nothing. It's all natural. Okay. After the incident happened, we can see from the down there, from the down the foothill there, we can see a lot of open, like those clear area at the valley that have been eroded down. Okay, but now definitely after 2 years plus, the vegetation grow back lah. Okay. This question very difficult to answer. I explained this already. I think there's no definite answer. Whether it happened already, it will happen again. Just like flood, it happened already. Whether it will happen again at the same location, that is a probability things. Okay. But I think, as I mentioned, we need a master plan. It's a better approach. Okay. Thank you.
Yep, agree. Just sharing a little bit of my own 2 cents. I'm aware that there are some projects in JPS. JPS is starting to do this thing as well. What they do is that they have an additional scope where they have geohazard specialists coming in. The geohazard guy will do geological mapping, and then they do some landslide and rockfall analysis. From there, they come up with a geohazard susceptibility map, and from the susceptibility and the risk map, from geohazard, you know where the landslides, the occurrences are, probability are. Then they start to formulate a sediment management plan. So that's one way that I see some dams are starting to do that. JPS also starting to do that. Just some 2 cents. The next question, Mr. Wan Muhammad Asri. The question is, what are the geological and geomorphological characteristics of the site?
Okay. I'm not a. We have a geologist for this design also. I can just share a bit of only the normally debris flow happening is when the soil is collovium type. Okay, in this Gunung Jerai, the formation is I forgotten is that actually the bottom very shallow. The bedrock is very shallow and steep. Okay, on top of this shallow bedrock, a deposition of boulders and soil on top of it. That's why the trees that grow along this area Gunung Jerai, the root cannot penetrate deep. Okay, so when that's why there's the trees can be easily fall, or when there's a heavy rain, the soil can be easily eroded down. That's what I understand from the study of the geologists. I hope I can answer that with my limited knowledge on that. Okay, thank you.
Okay, we have 2 more questions to go. I think that we will close the questions, and we're not accepting any more questions because we want to start sharp 3 o'clock. We want to start the second topic. So we have another 2 more questions over here. This one is from Mr. Tan Kai Boon. Place of disposal of the materials, I think. Where do we dispose? Yeah.
At this moment, the volume is not that big lah. I also not sure where's the contractor dispose the material, but definitely I think this have been discussed between the contractor and JPS for the designated place to dispose it. I'm not so sure. Okay.
Yep.
Sorry for that.
Last question over here we have from Mr. Wan Muhammad Asri again. How will the Sabo structure be adapted to potential changes in site conditions or their reflow patterns?
Oh, that means if actually to be frank if the Sabo structure, let's say it found that the Sabo structure was undersized, oversized, normally there's no issue lah. Let's say if it's undersized or the climate change, then you found that the Sabo structure may be not sufficient. The only way we can do is to build the Sabo structure a few more at the upstream to control it. Okay, that is one way to actually not to demolish the old structure and build a new one, but we can actually have a smaller one upstream of it to control the debris and rocks boulders. But easy say than do lah. I know that Gunung Jerai is very steep and not easy to find a road that we can put a smaller Sabo structure upstream. Importantly is actually is a forest reserve. We cannot actually clear a road, simply clear a road and cut down trees to create an access road to maintain the Sabo structures. So there are challenges to all these things. Yeah. We recognize that if, let's say, now we design for 100 years, maybe in 20 years time, then the 100 years become 50 years or 20 years. Then we need to do a sensitivity analysis, or we need to, how do we increase the size behind the Sabo structure itself to contain more debris and boulders. This actually can be adapted lah. Mainly is the storage volume lah. Okay. I hope I answered the questions.
Okay, I think we are just about on time. So we want to take this opportunity to thank Engineer Dr. Wong for a very good and very informative presentation. So we would like to move on to the next speaker. I will just quickly read out the synopsis of this of a topic. So our next speaker is Engineer Technologist Nur Aisha. Okay, this is the synopsis of the topic. Rainfall has been increasing, has increased recently. The frequency has skyrocketed. So the issue of climate change has been impacting flood management in Malaysia. And of course, there's rapid urbanization leading to increase in runoff. And there are many different approaches in managing flood, starting from the conventional structural measures, as well as the newer, the more green, eco-friendly, non-structural measures, blue water body solutions. So I don't know, Aisha should be providing a bird's eye view from the perspective of the IB on how to improve flood risk management in Malaysia. So without further ado, I'd like to pass the floor to Engineer Nur Aisha to present her talk. Thank you.
Okay, thank you, Engineer Chok, for the introduction. Good afternoon, everyone. So today I'll be talking and I'll be sharing with you the overview of flood management in Malaysia. Okay, my presentation will be divided into 4 sections, where the first part will be seeing on the introduction, I will touch on the Malaysia climate, what is our flood condition at the moment. Secondly, we'll discuss the idea on how climate influence on hydrological scenario and flood in Malaysia. We will see the rainfall distribution and the potential future rainfall distribution. The third one, we will look into the strategy. What are Malaysian initiatives in flood management? Basically, we will touch on what are the project principles, and I'll be sharing with you what DID is doing in managing the flood. And finally, we will discuss on the challenges. You'll see, as we know, implementation without challenges are actually unexecuted plans. So we will talk on the issues, as well as a little bit of recommendation snippets from the disaster risk reduction team that visited Malaysia following the big flood in 2021 from Netherlands. And I'll share a little bit on what are their recommendations, as we will most probably enter into MOU with Netherlands in looking how to improve our flood management in Malaysia. Okay, so this is our Malaysia, our land. So we have about 330,000 kilometers squared. This is our total area, with 32.2 million of Malaysia's population. We have about 2,986 numbers of Malaysia's river catchment and annual rainfall of 3,000 millimeter per year. So that is a huge amount of rainfall that falls in our country yearly. So this is where the rainfall goes. 971 billion cubic meter of annual rainfall, which is about 3 times the global average. This is very much affected by temporal and spatial factor. 412 billion cubic meter went off through evaporation. 61 billion cubic meter goes to our groundwater recharge, and the balance of 494 billion cubic meter, which is about 51%, is the surface runoff that we have to manage. So this surface runoff, 17% being taken up by dam storage, but being released back about 1.2% from WTP. This is based on SPAN study, and this 51% of the balance flows through our 2,986 river network, and 29 of our rivers are polluted based on EQR report latest last year, and 80 to 85% of the surface water is released to the sea. So this is basically what we have to manage when we come to flood. Okay, this is our flood dashboard. This is based on our study based in 2012. We are currently updating these figures. I am expecting the new figures will be released next year. So 21% of our population are affected by the flood. We're talking about 5 million people, with annual average damage about 36 billion per year. And 10.1% of our country is flood-prone areas. If I'm not mistaken, it's about more than 60% of our area is 100 meters below sea level. So what are the type of floods that we have in Malaysia? The first one is the famous one, the monsoonal flood, which is the seasonal flood due to long duration rainfall during the northeast monsoon, which is currently happening in our East Coast area, Kelantan, Terengganu, and Pahang, and parts of Johor. Next is flash flood. This is very famous in Malaysia, in KL, in Shah Alam. So this is due to high intensity, short duration rainfall that occurs mostly in urban areas, coupled with inadequate drainage and storage system. And finally is the coastal flooding due to backwater effect from tidal influence affecting the lower reaches. Okay, major cause of flooding. We can classify the major cause of flooding into two. The first one being man-made, which we can try to mitigate, and the second one is the natural causes. Okay, the first one being the land development. The more land we open, we increase the discharge, we increase the surface runoff, floodplain encroachment, changes of land use, land is getting more impervious. So this all contributed to increased discharge, hence more flooding in Malaysia. Secondly is the river obstruction. We can see there are some bridges with very low surface level. It actually disturbs the water flow. We have structures in rivers. We have pillars in rivers, MRT or LRT pillars are in rivers, as well as rubbish. Rubbish also cause disruption in our river flow. The third one is insufficient drainage. So some of the drainage, we have to understand that the drainage system is there for quite a long time with based on past development. Current development is very fast paced. So the current drainage is insufficient to cope with increasing of runoff. The fourth is poor maintenance. It is very high operation cost to maintain rivers and drainage due to our own self, because of sedimentation, because of rubbish. Those are the things that we can try to avoid. Next, the natural causes of major flooding. The first one is extreme rainfall. For urban areas, if we receive 60 millimeter per hour rainfall in urban areas, is considered extreme. As compared to rural areas, 6 hours of continuous rainfall may cause flooding in that particular area. Secondly, is on the tidal effect. We have high tide ranging from 1.8 to 6.1 meter, and combined with storm surge, this will definitely bring flood, especially at areas like Klang or, if I'm not mistaken, Kluang. And the last one is the low-lying areas. This is the one I said, 61% of peninsular Malaysia is below 100 meters above sea level. So let's see a little bit on the historical flood. 1971, we have KL flash flood with 24 deaths. So this is the starting where Department of Irrigation and Drainage being entrusted to manage flood in Malaysia. Before this, DID is focusing on irrigation, more on agriculture. So due to 1971 flood in KL, DID was trusted to manage flood in Malaysia. Then we have in 1996, storm in Sabo, 241 deaths with 97.8 million of damages. We have in 2000 flood in Kelantan, Terengganu with 15 deaths and 100,000 of people affected. 2006 flood in Johor with 18 deaths, 489 million in damage. 2008 flood in Johor, 28 deaths with 21 million in damages. 2010, where 2/3 of Perlis was flooded, 50,000 people affected and 45,000 hectares of paddy field destroyed. I believe this flood is very, very significant to most of us. The yellow flood in East Coast back in 2014. We recorded 25 deaths with 500,000 people affected, causing about 750 million USD in damages. 2017, Penang experienced the worst flood with 7 deaths. 2021, where the KL, Selangor, and Pahang flood. If you remember Shah Alam, this was one of the worst flood that hit that area in 2021. This flood prompted to project Devatan Bajir Berkeutamaan Tinggi that we are currently working on now. 2022, last year, there was a flood in Rantau Panjang, and yet to see this year what's coming in for Malaysia. Okay, let's see the rainfall distribution. So this is the temporal and spatial distribution. If you can see from 1978 to 2017, you can see that the intensity of the rainfall is increasing. You can see the darker the color, it's getting, you can see in East Coast, it's getting more intense as compared to 1978 to 1980s. And this is in Sabah. A significant increase can be seen in Sarawak from 1978 to year 2000. So this is based on Kajian Penyediaan Perubahan dan Taburan Hujan di Malaysia, a study by GPS and Nahrim back in 2018. So let's see how's the rainfall trend. Back in 1950s, as compared to now, 2023, Numbers of wet spell where we consider as rainfall with more than 100 millimeter per day for 3 consecutive days has increased. It's showing increased trend line. And if you can see on the smart tunnel operation, the numbers of operation has increased, particularly in year 2020. 2022, I have yet to receive for the 2023 record. There are a few times that we have to operate on mode 4, where all tunnels are being closed to channel the water to avoid big flood in KL. So you can see the trend nowadays. The rainfall is getting heavier. Smart tunnel is operating the operation is increasing from year to year. So we can see that it's getting wetter in Malaysia. Okay, what is the potential future? Based on study conducted by Nahrim, it is expected that the temperature for Malaysia will be increased, and the rainfall distribution will also increase up to about 32% for northeast area. For southern is about 2.9%, 3%. And at our area, at the central area, is about 8% increase in terms of rainfall. So more rainfall means more water that we need to manage, more surface water that we need to manage. And if no flood mitigation projects is in place, we are expecting more flood to come. So what is the strategy being upheld by GPS? We hold to these 4 principles. The first one is we would like to create for resilience. Number 2, it's good to build with nature. Number 3, we have to bring back our beaches as that would be the damper for storm surge and high tide. And most importantly, we have to make room for water. We have to respect the room that the water needs. We are not against development, but we have to understand that rivers will try to find back their route, and that is the reason why we have to make room for them. So when we talk about creating for resilience, we have disaster risk reduction strategies. We have to build better structures and include climate change factor CCF in design. We also consider of higher ARI in certain areas where budget permits. Second, for building with nature, water is prioritized. Water must be eccentric. It should be treated as the catalyst of economy. We also have to reconsider our method of construction. Let's try into circular construction, whereby we should go for zero waste. Next is the introduction of river trail. River trail actually aims for better guardian of our rivers, so as to reduce river reserve encroachment and also enhancement of river corridor. So these are all intangible. The intangible effects are economic blooms in that particular area. Next is bring back the beaches. We are looking into beach nourishment, sand bypassing and beach trail. And room for water, we have to place setback for river and coastal development. We have to preserve our natural defense, our pokok, paya bakau and everything, and also preservation of wetlands. These are the overarching principles for infrastructure development upheld by GPS at the moment. Okay, when we talk about flood management, we can't run away from climate change. So these are the initiatives that we are looking at to go for resilience to climate change, which initiative number 1 is integration of climate change adaptation on policy and guidelines. Second is we improve our hydrometric network coverage. The more data that we have, we can predict better, we can improve our design better. Next is improvement of technologies in engineering practices, looking into renewable energies. And finally, improvement of warning system for future flood and drought. Because we have to understand that some areas, not much can be done in terms of flood mitigation, but we can try to create resilience among the communities to face flooding and drought. So, okay, what do we do? Firstly is we look into the policy, integration of climate change adaptation in policy and guidelines. Back in 2009, we have a policy statement to ensure that climate resilient development to fulfill national aspiration for sustainability. So this particular policy instrument to harmonize and integrate with national priorities, measures on TPA, mitigation and DRR. It consists of 5 principles, 10 strategic thrusts, and 43 key actions. I'm not going to elaborate more on this. We also have Malaysia's second national communication to the United Nations Framework Convention on Climate Change, UNFCCC. So we have agreed to prepare a report periodically on national greenhouse gas emissions and measures taken to address climate change. So in 2022, 8 initiatives have been declared by Malaysian Climate Change Action Council. The first one is the implementation of high priority flood mitigation projects ataupun dalam bahasa lainnya projek Jabatan Banjir Berkeutamaan Tinggi. We are very busy doing this at the moment. Next is the long-term solution on flood mitigation, urban drainage and coastal infrastructure construction. We also look into increase of design criteria from 100 ARI to 200 ARI with CCF for flood mitigation and coastal band. Off-river storage, construction and upgrading of dual function off-river storage. Strategy number 5, renewable energy. We try to utilize renewable energy or energy-saving infrastructures in flood management. Flood forecasting and warning. Yeah, currently the latest being Audit Negara report, but we are determined to improve our flood forecasting and warning system. Next, on the plans and guidelines, GPS has been very active, preparing various studies of integrated river basin management plans, Plan Induk Saliran Mesra Alam, National Water Balance, Flood Hazard Map, Flood Risk Maps, and Integrated Shoreline Management Plan. And finally is just like what Dr. Wong presented just now, construction of Sabo infrastructures for debris flood. Okay, federal government through budget 2024 has announced that allocation of 11.8 billion to conduct 33 high priority flood mitigation projects. Most of these TBBT projects will be managed by DID, but other agencies involved are Malaysia and Water Supply Division and RCC. We target that this project will be completed by 2030. We are in the midst of tendering. Some has been awarded, some are during tender board, and some are on the way. And the guiding principle for TBBT projects, some of the projects, the flood protection will go up to 200 ARI. We are encouraging nature-based solution. We combine the gray and green solution. So gray reflecting to the structural and the green is reflecting the natural nature-based solution. We are promoting retaining water at source by utilizing detention ponds, multi-usage of detention ponds, and all this project must be completed by 2030, as mentioned before. So let's see a little bit on construction of Sabo dams. Completed 2 numbers and another 22 numbers are being planned to be constructed. So let me share. This is actually Sabo Dam, the one that Dr. Wong shared just now. This is the view. This is the video of the area. This is the downstream area moving up. Am I right? Or okay. Okay, now I'm sharing with you now the slide is showing on the flood forecasting. Okay, how do I start? Okay, we have some observed rainfall transmitted to the flood forecasting data center. We have water level station. So these are the data that being transmitted. Rainfall data, water level data, the global forecast system, all being fed into the data center, as well as Map Malaysia also supply us with the NWT the numerical weather prediction. All this data being processed and pushed through our modeling system at Operation Center, which is Pusat Ramalan dan Amaran Banjir Negara. And once we notice or we forecast a flood, Praban will disseminate the flood notification to the NDCC, NADMA, for warning dissemination. The targeted dissemination is 2 days ahead to Army, hospital, police, and fire rescue. All this done by NADMA. And we also have some sirens. And we are going to disseminate warning to the point of interest identified as flood risk area. So the target is flood prediction for 7 days ahead and warning dissemination 2 days ahead of time, which pretty much depends on the forecast data, weather forecast data from Met Malaysia. So to improve our flood forecasting and warning system, we have increased our hydrological stations. For example, equipment and systems are being upgraded. We have about 1,458 stations. We increased our rainfall station from 443 to 1,100, water level station from 320 to 650 numbers. We have soil moisture, 50 numbers, evaporation station, 20 numbers. But if we compare our rainfall station coverage ratio compared to Bangladesh and Japan, we are still far away. We have to catch up to increase our accuracy in flood forecasting. We have to increase our rainfall station coverage. Next, we have preparation of flood hazard maps. So what are the process? Flood hazard map is actually a map that we produce to show potential areas that will be flooded under certain ARIs and under various ARIs. So we produce this map using hydrodynamic modeling and 3D data, and we will demarcate the potential flood area and flood depth at various ARI based on current and future land use, together with and without flood mitigation projects, so that we can see whether our flood mitigation projects will bring good outcome to that particular area. So at the moment, 47 maps has been completed since 2012, and we are expecting to share this map with the public in 2024 as practiced in US and UK. However, it is not a smooth sailing journey to share the map with the public, as we also receive resistance from some parties. So we are ironing it out before we can share the map with the public. Next is looking into re-strategizing operation of dam. For example, in November 2021, TNB has reduced their water level in hydropower dams to provide extra storage capacities for upcoming flood during monsoon season. And this is also to promote gradual release to avoid gushing of waters flowing downstream for getting worse during the monsoon. We also do the same thing in Rata Panjang. There is a kolam Uban there. We have discussed with KADA to reduce the water level so as we can provide more storage capacities to face or to get ourselves prepared for upcoming flood in monsoon season. Next is communication, education, and public awareness. Information sharing is very vital. So GPS has this website that you can have a look, www.publicinfobanjir.water.gov.my, whereby in this particular website, you can have a live feed on rainfall and water level information. And this website also will disseminate a warning for flood forecasting and landslide risk information at selected location. Feel free to visit this particular website for more information. Met Malaysia also has produced a My Cuaca app. It will disseminate information including daily weather forecasts, weather warnings, earthquake and tsunami events. This is more to create resilience among the communities and publics, so as they are more prepared to face the casualties, the flood. And MKN also is blasting information through its Telegram channel at MKN Rasmi. So the information from Public Info Banjir, from Praban will be fed through this particular Telegram channel for public viewing. Next, we also look into utilizing renewable and energy saving in flood management. The first one, strategy 1, we encourage development of prototype for renewable energy saving flood management system. We are looking forward to expand usage at pump house gates, currently applied in street and pump house piping system only. Next, we are studying the system effectiveness to minimize wastages. And number 3, we have to ensure that the system proposed must be practical, reliable, and sustainable, as well as affordable in terms of cost, capital, and operational expenditure. Okay, this is the summary of evolution of flood management approach in Malaysia. Okay, in 1932, we are basically ad hoc basis. Ada banjir, kita buat perubatan banjir. So flood in agricultural areas were managed through river conservancy and river training work. Then in 1971, where after the KL flood, there was a catch-up plan. We tried to manage flood in rural and urban areas through implementation of structural projects. And this was when Hydrological Division was formed as national custodian of hydrological data. At this time, the approach was more towards rapid disposal. We want to get water out of the system as fast as possible so as we can avoid flooding. But in 2000, we have introduced a very different method, which is control at source, a very famous approach in MASMA. So MASMA was introduced to control at source, so we can control the Q peak before and after development. Then in early 2010, we introduced the integrated flood management, where in this particular approach, a balanced approach between structural and non-structural measures were given priority. And now we are in 2020s. Nature-based solution is preferred, where sources to sea approach where room for water is respected. So more river reserve, we have to allow more water water to move in our areas. Okay, let's look into the challenges and the issues that we face. The first one, hurdles in promoting nature-based solution. There is always conflicting demand for land use. We know land is state matter. So tanah-tanah tepi sungai, all the land near the rivers, near the coastal is of high value, very nice to be developed. But we want to keep it for water. So it is a very conflicting demand for land use. We have to try to strike balance between development as well as flood mitigation. Second, resistance in information sharing. Sharing flood hazard maps raised some concerns from various entities. For example, when we have the flood hazard map being shared into public, there is a risk of your property value will be dropped when people see that your house is within the flood envelope. So those are the concerns raised from some entities, resulting into resistance in information sharing. Next is conflicting SOPs for dams. Okay, for non-flood mitigation dams, for example, hydropower dam or water resources dam, we want to keep the head as high as possible. But then for flood mitigation, we want them to lower it so as we can have extra storage. So these conflicting SOPs cause refusal in order to reduce storage capacity by dams operator before monsoonal season. So a lot of negotiation needs to be done to come to a win-win situation for everyone. Okay, after the flood in 2021, back then, the Prime Minister back then has talked to Netherlands and seek some help to see how can we improve our flood management in Malaysia. So these are some of the recommendations by the disaster risk reduction team from Netherlands that I would like to share with all of you. Number one, we have to shift from reactive to proactive approach. So when we talk about this, GPS can't stand alone. Local authorities, developers, state government, all of us have to work together, because when you talk about flood management, it's not solely on structural measures. Do we build bunds or bypass or floodgates or provide water pumps? But we also have to look into land use planning. We have to look into river reserve. All these things needs to be looked together holistically. So there must be a shift from reactive to proactive approach. So option two, highlighted by the team, was strengthen knowledge and data sharing, sharing models across jabatan, across agencies. So those are one of the option recommendation given by the team, as well as sharing flood hazard map to the public. Number three, we have to acknowledge that there are underrepresented groups and vulnerable communities. We have to rope them in to make flood risk reduction efforts more inclusive. And finally is to promote education and awareness. This should be our continuous agenda, because we have to look flood differently. Flood is not only disaster, but it is also an opportunity. So we have to keep on promoting education and awareness to the public in managing flood better. So this is the loop diagram that one of the ideas being thrown by the DRR team to Malaysia. If you look at the traditional pathway, what we do is like just pumping and raising dikes. So this will provide more flood protection and reduce the hazard. You will feel more safe. However, in the alternative pathway that being proposed by the team was, instead of having dikes and pumps, why not you develop your mangrove? So this can give you flood protection and reduce hazard. It also help into spatial planning, flood-based agriculture. It will also help your sedimentation. They ask you to look it differently. Let's try to solve our problem differently compared to our orthodox flood management ways that we have been used to do. In terms of river flooding, we also use pumping and raising dikes. So they ask us to look into spatial planning, give space for rivers, store more water, and you can introduce some dikes. And all this needs to be done together to better reduce the flood hazard at flood risk in Malaysia. Okay, I would like to leave you with two questions before I end my presentation. The first is, do you think we live better than our ancestors now? I'll leave you with this question. And the next question would be, will our next generation live better in future with what we are doing now? So as we are the engineers, we are the one who's going to build all the dikes. We are the one who's going to build all the bunds. We are the one who's going to propose all the river diversion. Will we leave them a better world for them to live in the future? So with this, I thank you. Back to you, Chop.
Thank you very much, Engineer Technologies Aisha, for the presentation. A very good overview about flood management approach and strategies in Malaysia. So we will proceed with the Q&A session. So I would like to invite any participants who have any questions that you'd like to ask. You can drop your questions into the chat box. We have one question over here. A question from Mr. Wan Muhammad Asri. What are the emerging technologies in drainage engineering for flood management?
This is a very broad question, Mr. Azri, but when we talk about imaging technologies in drainage engineering for flood management, there are a few aspects that we can look at. Number one would be beam usage in planning our design and construction. The software that we can use in flood management. Other than that, we have to think out of the box. It is not about technology, but it is rather of being creative, of using the space that you have, instead of just having big chunks of culverts, big chunks of drains. Can we
Berapa game ni kita? Oh, okay.
can we make use of the room that we have to manage our flood? So it's not only about technology, it is also about creativity of solving the problems on how to make use of the land that we have to provide space for water.
Okay, thank you. We proceed with the second question over here by Engineer Zainal Abidin. Please confirm the annual losses due to flood. Is it RM 60 billion or is it RM 6 billion?
It's 36 billion per year. The annual average damage is 36 billion per year based on our study back in 2012. We are updating the figures. I'm expecting that we can release the new figure next year. Thank you.
Okay, the third question, a question from Mr. Wan Muhammad Asri again. How can we balance the need for flood protection with the preservation of natural ecosystem?
Okay, it's lovely to talk on this. I've just got back from Amsterdam last 3 weeks, attending Amsterdam International Week, Water Week, looking specifically at flood protection. They managed to give flood protection of 10,000 ERI. That's pretty huge, 10,000 ERI. So you can imagine how big the storm surge barriers. They're not talking about tidal gates, they're talking about barriers. It was very huge, about 300-meter length. They make use of because of the system there, they use public fund where the public needs to vote and you have to get public buy before you can conduct any projects. So the public insisted on, to have more drains. So they have the areas beside the rivers, they allow for the water to spill and to shift the houses far away from the river system. Next, before this, if they used to, when they want to strengthen their dikes, they will use the normal techniques with rock development or whatnot. But recently, instead of doing that, what they do was they introduced sand barrier. Just basically like beach nourishment. They put some sand at the side of the dikes, and over the years, they develop some areas. It acts as a dampen to the dikes, and it promotes new ecosystem for the area, more flora, more fauna, and fisheries is getting better. So that's how they do it. So basically, when we want to talk about how can we balance the need for flood protection with the preservation of natural ecosystem, the answer is simple. We have to work together. It's not solely the engineer's mind or the engineer's thought that needs to be considered, but we also have to take into consideration the areas that we want to protect. So we have to understand who are the stakeholders there. If there are farmers there, so we have to make sure that their needs are being taken care of. Thank you.
Okay, we still have time, so we can still allow for some questions to come in. I would like to invite any participants who still have any questions that you'd like to raise it to the presenters. You can drop it to your chat box. We have two coming in over here from Mr. Wan Muhammad Asri. how can we effectively manage flood risk in urban areas with limited space for traditional flood control infrastructure?
Okay. Currently we are preparing flood management master plan for Lembangan Sungai Kelang, which covers the area of KL. We have to go towards non-structural measures. We have to try to look at the possibility of reducing the temperature in the urban areas so as to reduce the occurrence of high intensity, very localized rainfall, because this is the cause of flooding. Besides producing more green areas, we have to make use of the rooftops and whatnot. Yes, there were some ideas before when we were hit by the big flood back in 2021 to have tunnel, but we have to look thoroughly whether it is feasible to be conducted in Malaysia or not. People were quoting Japan at that time, but we have to remember Japan water surface water is crystal clear, whereas ours is devastate. So imagine having tunnels or having underground storage, how much sedimentation will be under there. So we have to also utilize more multi-purpose storage of online phones, and I think basically that's it, and control of upstream.
Okay, thank you. We move on to the next question. Question by Engineer Zainal Abidin. What is the risk of not meeting the plan protection system by 2030? I repeat the question again. What is the risk of not meeting the plan protection system by 2030?
Terlepas lagi. Tak apa dah masuk, dia terlepas.
Okay, what is the risk of not meeting the plan protection system by 2030? All these projects most of the projects are being tendered through design and bid contracts. So the contractor should have enough control except for land acquisition. So if the plan protection system is not completed by 2030, there is a possibility of flooding still occur. The flood problem will still be there, and let's cross our finger this thing not happen. Okay, I want to complete this project in 2050.
Okay, move on to the next question, right? Mr. Wan Muhammad Asri. How can we address the increasing frequency and intensity of floods due to climate change?
Okay, due to climate change, we also have reviewed our HPs, our hydrological procedures, where we have included the climate change factor when you want to calculate your design storms. So this is the way we address the anticipated increased rainfall in our designs to manage flood better. It's a very short and precise answer. That's what we are trying to do now.
Okay, we have another question over here. Similarly by Mr. Wan Muhammad Asri. How can we develop sustainable funding mechanism for flood management projects?
Sure. I think I am not in position to answer this question. But among just like carbon footprint, maybe water footprint, we have to introduce something like water footprint, similar to carbon footprint. So, for example, if you have opened up a land that cause increase in surface water at a certain area, so that increase must be compensated elsewhere within the river catchment or within the river basin to help the government to control the surface water within that particular river basin. I think that would be one of the things that the government is viable to look at. Yeah, we can't keep on spending on flood mitigation all the time.
Okay, question from Engineer Dr. Wong Wai Sam. With so many projects being tendered out and finished in 2030, how will these projects impact the construction material, labor, and machineries?
I can't answer this, Dr. Wong. I have no idea. And but the projects are scattered throughout the country. So yeah, can't really answer. Sorry.
Okay, we can allow a few more minutes for any other questions to come in. Are there any other questions from the floor? So kalau tak ada, before we end, I would like to invite everybody to open up your video so that we can take the group photo of all the attendees or the
Engineer
participants.
Chok,
Yeah.
Datuk Lim have raised his hand.
Oh yeah, sorry, tak nampak.
Datuk, you may unmute yourself, Datuk.
I think I pressed it accidentally. I have actually no questions, but obviously to congratulate DID for the effort taken to address flooding. I still feel that actually the whole issues of flooding need to be addressed holistically. We definitely need both the structural as well as the non-structural approach. So certainly, I think things like land use management has to be given very close so-called considerations in addressing the so-called reduce the flooding areas. Flooding has no end one. I would say that it depends on to what degree of intensity we want to actually protect the flooding area. In terms of the return period, if you're going for things like 200 years return period, protect 200 years, obviously the cost will go up probably more than double. So I think the question is whether do we have the so-called financial resources to address the flooding issues in Malaysia. We need to balance. There are so many other sectors also need funding in Malaysia. So I think it has to be addressed holistically. Thank you very much.
Okay, thank you. So I would like to invite everybody to turn on their camera. We will take a snapshot of all the participants right now. In a moment now. One more minute. Okay, we're done. So with that, I think we like to give a round of applause. Although it's virtual, we like to express our gratitude to the two speakers, IR Dr. Wong Wai Sam and IR TS Nur Aisha for the very good presentation. And we also like to thank all participants who have made time to join us in our webinar series. So with that, we will end the session for today. Thank you very much. Thank you.
Thank you all. Bye-bye.
Bye.
Okay.